Would you please welcome Professor Bill Laurance?
Thank you, Kerry. Good morning, everyone. It's a real honor to be here speaking before such a distinguished group of delegates. I was particularly pleased to see our mayor here, Bob Manning. Bob presided recently over a ceremony in which I became an Australian citizen, so quite happy about that. And I should emphasize I'm not just an Aussie, I'm a Queenslander, so go the Maroons. And I'm also very pleased to see Jason Pomeroy arrive. Paul Gadek, who's one of the local organizers, mentioned that Jason might not be making it. And he said, you're either going to be talking very fast or very slow. And I wasn't literally going to know until right up to the last minute. But I'm pleased to say I will be talking probably fairly fast. I'll tell you a little bit about the context of what we're going to talk about here. Roads are an absolutely massive issue, and they're going to be a massive issue in the future. And people's perspective on roads tend to vary very much depending whether they're more oriented towards issues like economic development and social development or environment. And what I'm going to talk about today has been an effort to try to look at these competing realities and to look at the kinds of factors that influence the risks and rewards of road building around the world and what kinds of strategies we can try to adopt to hopefully maximize the social and economic benefits while minimizing the environmental costs. One of the reasons why, as an environmental scientist, roads have our attention so much is that we're really facing an unprecedented era of road building. We are entering right now the most explosive era of road expansion ever in human history. The International Energy Agency estimates that we're going to have something on the order of about 25 million kilometers of new paved roads by the middle part of this century, and that's enough to go around the world more than 600 times. And about 9/10 of all those roads, new roads, are going to be occurring in developing nations. And just about everywhere you look in the developing world, including many of the world's last major wilderness areas, what you see is a remarkable avalanche and proliferation of road building activity. And this can cause quite a lot of profound effects. This is just one example here. Now, I sort of grew up, reading books like Joseph Conrad's Heart of Darkness and thinking of places like the Congo as one of these last, magnificent wildernesses. In fact, if you look at the Congo Basin now, what you see is that it is crisscrossed by many different roads, and if you zoom in on a smaller spatial scale, you in fact see those are just major roads, which you actually see also are whole networks, spider webs of logging roads as well. As a consequence of all this road building, there have been a lot of profound changes happening in the Congo Basin. So what I want to do right now is talk about some of the ways that roads affect the environment, and there's sort of direct effects, and there's also indirect effects, and so we want to talk about both of those. One of the obvious things is that when you build a road, you destroy some habitat. There is some habitat loss. Typically, what road builders do is what's called cut and fill, so they'll cut the higher parts of the landscape and they'll use that to fill lower parts of the landscape. And this is an example of a gold mine in Panama, and you can see there's a clearing of a few dozen meters wide there, and there's been some habitat loss occurring there as well. There's also what we call edge effects, and edge effects are ecological changes that tend to happen when you get two very physically different kinds of environments right next to each other. So you take a tropical rainforest, which is dark and humid and very moist and has very little wind, and it's an ancient environment that's been around tens of millions of years, and many species have evolved to be specialized and live in that environment, and you put it next to a hot road, hot road, and you get a lot of physical changes happening in the environment. And this is just some examples. I've been working in the Amazon for about 20 years now. These are some of the different kinds of edge effects that we have measured next to clearings, like roads, in the Amazon. And you can see here, there's really a remarkable diversity. I'm not going to try to talk about all these, but a remarkable diversity of physical changes and biological changes and changes in disturbance regimes and invading species. And some of these things can penetrate, hundreds of meters into the forest interior. So there's a lot of changes that can be provoked by road building that don't just affect the road itself. Here's some example. My wife, for her PhD, actually studied the responses of birds in the Amazon to road building activity there. And you can see here, these are net lines, mist net lines, where they catch birds that are set up 10 meters from roads, 70 meters from roads, and 130 meters from roads. And you can see some of these different groups of birds really decline in abundance as you get closer and closer to roads. The roads just seem to be a foreign environment. It's exotic, it's strange to them, and they simply don't like to don't like to get very near to that. There's other kinds of changes that happen by roads in tropical environments where we can have thunderous rains coming down at certain times of the year. It doesn't matter how many culverts you put beneath roads, you're almost always going to get some inundation of areas, some impeded water, and that's going to flood areas that can kill vegetation and have impacts. Roads can also cause a lot of erosion, particularly dirt tracks and that type of thing, but also the margins of the verges of roads. In some tropical environments, you can get very intense erosion occurring. Typically, for instance, after an industrial logging operation, a selective logging operation, we see about a 10,000-fold increase in the amount of sediment in streams draining that area. So you can see really big increases in erosion and sedimentation of streams, which can have quite a lot of impacts on aquatic life. Of course, there's roadkill especially when you have fast-moving vehicles, and there's certain kinds of species that tend to be particularly vulnerable to this. So it's things that are slow-moving and have poor eyesight. A lot of things tend to freeze when they have a car coming in their direction, things that forage along roads. There's various kinds of species that we recognize as being especially vulnerable to being killed by traffic. And then you start getting into things like barrier effects, and this surprises some people to realize that there are many specialized species, particularly in things like tropical rainforest environments where you have, again, these ancient environments and things have become so specialized. But here's just an example. My wife, as part of her PhD work, there are certain species of birds in the Amazon that mate with a single mate their entire life. They're monogamous with this one mate, and they have an incredibly strong fidelity to their territory. So if you move them off their territory, for instance, you can take one of these birds, you can put a little radio collar on it, and you can catch the male, for instance, and you can move it 2 kilometers away in the forest, and that same day, or certainly the next day, it'll be back on its territory. And this happens essentially 100% of the time. You can take that same bird and move it across a 60-meter wide road clearing, and it will not go back. It will go up and down the edge of that clearing, and it will not return to its mate. And there's no more powerful motivation that you can imagine for an animal to try to get home, to try to get back to its lifelong partner. And that just shows you how powerful these effects can be. Roads are also important corridors for invasions for lots of different things. Things like cane toads in some kinds of rainforest environments, and lots of other weeds and other kinds of species. I have to confess, by the way, I found out recently that that's actually a fake photo. I thought that was the biggest cane toad on the planet. It's a good fake photo, though, yeah. And then we start getting into things like secondary effects. And in many ways, the secondary effects of roads, by greatly increasing physical accessibility, are probably more important than their direct effects. And one of the things that we see in many kinds of environments is that when you put roads in, you get a big incursion of hunters, many hunters coming into the area. Sometimes loggers and others are also big hunters themselves. This is some work that we've done in the Congo Basin in Africa. And this is an area with a very low human population density and just a little bit of hunting. But even so, what we see is a decline, even inside protected areas, we see a decline in the abundance of forest elephants as we're getting closer and closer to roads. But outside of the protected areas where we get a little bit more hunting, we in fact see even a steeper decline. If you start looking at other places in Africa that have higher population densities where you've got more hunting activity happening, what you see is this road avoidance actually occurs over much larger spatial scales. So this is some work that's done by Steve Blake and some colleagues. What they find is that when you get within a few dozen kilometers of roads, you get, firstly, a big increase in human activity. So this is things like seeing snares and shotgun shells and boot prints and machete marks, things like that. And at the same time, you get a dramatic decline in the abundance of forest elephants, okay? So if you juxtapose that kind of information with this explosion in roading activity today, what they've then tried to do is to say, where are our safe habitats now in the Congo Basin for forest elephants? And what you can see is that the places that forest elephants can now live and survive has declined dramatically. And as a result of the 50,000 kilometers of new roads we've seen in the Congo Basin, we have in fact seen an epic slaughter of forest elephants. Their populations have declined by 2/3 in this last decade. So the roads really can have a major impact on some kinds of species. Roads can facilitate illegal gold mining. We are seeing this all over in many different parts of the world, in Sumatra, in Borneo, in South America, in Africa. Again and again, we're seeing big increases in illegal and oftentimes quite highly destructive mining activity, such as illegal gold mining activity when new roads go in. Loggers both build roads and use roads to access areas, and so industrial logging is a major issue in a lot of tropical environments, in a lot of environments. And roads, of course, are also related to things like forest fires. This is the northern Bolivia right here. The areas in dark are major logging roads. The areas in red are forest fires. And you don't have to look at that very long to see there's a very strong correlation between where the roads are and where the fires are. This is in the Brazilian Amazon right here. And you can see here, this is 0 to 10 kilometers from a road, 10 to 20 kilometers, up to 40 to 50 kilometers from a road. This is the increase in major fires as you're getting closer and closer to roading activity. This is inside protected areas. So even within national parks and protected areas, we're still seeing an increase in fires near roads. We're just not seeing as much of an increase. And of course, deforestation. We see big increases in the footprint of deforestation near roads. We've recently just published a study in which we showed that 95% of all forest destruction in the Brazilian Amazon occurs within 5 kilometers of a legal or illegal road. And it turns out in the Brazilian Amazon, for every 1 kilometer of legal road, you have 3 kilometers of illegal roads. So that's a major issue there. And we've been doing a lot of work in the Amazon on issues like, in Brazil right now is in the midst of a $40 billion avalanche or tsunami of road building and other kinds of activities, major new roads and highways penetrating into the heart of the Amazon basin and some of the more remote areas of the Amazon. And we've done some work basically saying, what would the Amazon look like in the future if all of these projects that have been planned and that are being proposed, in fact, actually go forward, and if, in fact, forest destruction occurs in the Amazon or forest degradation occurs in the way that it has in the past. And just to give you an idea here of the way some of these roads can kind of play out, this area right here, this is the path of the first major road in the Amazon. This started off as just initially a razor-thin cut through the forest between Belém right here and Brasilia, the national capital. And that today, that initial cut that has been turned into a whole spider web of secondary and tertiary roads, has now evolved into what is basically a 400-kilometer wide slash of forest destruction across the eastern Brazilian Amazon. So you really can get major changes occurring as a result of this. So one of the real problems is that if we look at the capacity of environmental planners and people that do environmental assessment and mitigation activities, especially in developing countries, but even in the industrial world, what we see is that people are just being overwhelmed by the scale and the pace of road expansion right now, and there's particularly the projected road expansion in the future. People are feeling like, that work on these issues are feeling like the little Dutch boys with their fingers in the dike, and the problem is that the dike is just springing leak after leak after leak. The scale is truly astonishing. Now, as a result of this, and we've been working on road issues for quite a long time, with a colleague, we published a paper in Nature, which is actually the world's most highly ranked scientific journal last year, saying we need a different approach here. Looking at these projects and trying to evaluate them one road at a time is just not getting the job done. The scale of what's happening is too dramatic. And so what we need is some kind of global scheme in order to try to say, where should roads go and where should roads hopefully not go? Where are the costs going to be too high? So we proposed this idea. Now, one of the problems is when you do that, when you throw an idea out there, then of course you're obligated to actually try to do it. So for the last year and a half or so, I've been working with a very good group of collaborators, including a number of people here at James Cook University, including several of the people here are my postdocs, people at the University of Minnesota, also at Harvard, Cambridge University, University of Melbourne, and Conservation Strategy Fund in Costa Rica. So an excellent group of scientists and environmental planners and road experts and agricultural experts and with a whole and spatial modelers of people with a whole range of different kinds of expertise to try to say, can we come up with a scheme to prioritize places, the risks and rewards of road building? So one of the first things we wanted to do is to start off is to say, well, where do roads cause the biggest environmental problems? Where are the places that they really do cause the biggest sort of catastrophes? And one of the things that you immediately realize is it's the first cut into major wilderness areas. That is one of the worst places you can put roads because, again, what happens is that deforestation tends to spread contagiously. It's highly contagious spatially, so you can think of it like a tumor. But the problem is that once you get the initial road in, then you start getting secondary and tertiary roads, and so in some ways that tumor metastasizes, and the footprint of the impact of the road can increase enormously. So, and one of the worst examples is what we just mentioned, the road across the eastern Brazilian Amazon. So if you're going to try to actually manage and protect some wild areas on the planet, actually stopping the first road is one of the most critical things that you can try to do, and that is a challenging issue. But of course, roads also are very important for their social and economic benefits. And so one of the things that we wanted to do is to say, well, where can roads yield the greatest benefits for humanity? And where can we try to emphasize road building? And the issue that we tried to focus on is food demand, which is something that several people have alluded to already. Because of rapid human population growth, especially in the developing world, and because of changes in food habits, essentially it's projected that global food demand is going to double by the middle part of the century. And that's going to be an enormous challenge to try to feed that many additional people, produce that much additional food. So one key question is, well, how much additional land are we going to need in order to feed all those people? And the projections that turned out vary wildly, okay? One extreme of the projections, which is based on a very respected scientist in the U.S., he basically said, if we just continue feeding people and doing agriculture the way we're doing it today, we estimate that we're going to need, by the middle part of the century, an additional 1 billion hectares of land. That's an area about the size of Canada. Numbers like that just scare the bejesus out of environmental scientists like me. On the other hand, a group of agronomists got together and said, if agriculture could be improved and if productivity could be improved, we might actually only need an area of about 120 million hectares, which is an area about the size of South Africa. So, why do those numbers differ so wildly? Well, it's because of different assumptions about how agriculture is going to be done. And one of the key issues that we are arguing is that, in fact, one of the main prerequisites for high-quality agriculture in times is often transportation. Many parts of the world, particularly many parts of the developing world, like sub-Saharan Africa and parts of Latin America and parts of Asia, they've already cleared most of the native vegetation, but the farming productivity is very low. And if the farmers had better access to urban areas, to markets, they can get their crops much more efficiently to markets. They can get access to agricultural technologies and things like fertilizer much more cheaply. Roads can facilitate a whole set of social changes and economic changes that can really benefit local landowners. And so the idea is that if we can emphasize road building and road improvements in areas where we can improve and elevate food production where we've already lost most of the native vegetation, so there's not a high cost to nature, we can really realize some major benefits. And then what could hopefully happen is these areas, as their economies improve, they become more attractive. They may start to act as magnets and actually start to draw people out of frontier areas where they're causing a lot of environmental damage and more into these areas where we're going to be ideally focusing on agriculture. So that's the basic idea behind this scheme, is these two sort of contrasting objectives. So we ended up developing a so-called environmental values layer, which emphasized things like biodiversity and key habitats and things, and then this so-called road benefits layer, which is to say, where are roads going to have the best value for money? And I'm very pleased to say that we just published this in Nature again, which is the highest ranked scientific journal in the world, which may not mean anything to you, but in my little world, that's like getting your picture on the cover of Rolling Stone. Anyway. So here's some of the information that we put into this, into these models, into these layers. So we looked at biodiversity. One of the things we wanted to do is focus on endangered species, and so we know that endangered species, of course, are things that are critical that we need to be careful about conserving. We can see that endangered species are not evenly distributed. You get a lot of them in the tropics, a lot in Southeast Asia, certain parts of Africa, certain parts of Latin America, other parts of the Asian continent. Another thing we put in there was the amount of plant biodiversity. Again, not evenly distributed across the world. The tropical, humid, and subtropical areas are very high. Mediterranean environments are very high, and some other kinds of environments are high. And then we put those two things together, and we get a composite map of biodiversity. So that's one layer that goes into our model. We also look at things like so-called biodiversity hotspots. These are areas that have lots of species that only occur uniquely in a particular area and have also already lost much of their native vegetation, at least 70% of their native vegetation. So this is some of the most biologically critical real estate on the planet. These are absolutely vital areas that we need to focus on. So that goes into the model. We also look at so-called endemic bird areas and important bird areas. There's lots of bird watchers in the world, and they know the places that are critical migratory pathways and critical breeding areas and that have locally endemic species and things like that. So we put that in the model. We look at included the global 200 terrestrial ecoregions, which World Wildlife defined as these iconic examples of some of the 200 most important ecoregions on the planet. We included major wilderness areas because, of course, wilderness is very important as well. and frontier forests, and we put all that together, and we ended up with a so-called key habitat map. And then finally we looked at environmental services, looked at a couple major environmental services because it's not just biodiversity, but native vegetation does some very important things for us. One of the things it does is it locks up hundreds of billions of tons of carbon. And of course, if that carbon gets released, it makes global warming and climate change worse. So this is a map of the amount of carbon that you would lose if you knock down the native vegetation and you replace it with whatever the local crop is. So it might be soybeans or farming, cattle ranching in the Amazon. It might be oil palm in Southeast Asia. It just depends on what the local crop is. And that's the amount of, that will tell you essentially how much carbon emissions will result from destroying the native vegetation. And finally, an index of the amount or the impact of the vegetation on the local climate. For instance, we know that if you clear a rainforest, say for instance in Sumatra, and you replace it with oil palm, that on average the temperature goes up nearly 5 degrees centigrade. And that has an impact on things like disease and on agriculture and on simply the comfort level of the environment. In fact, local people really care about these kinds of changes. It's one of the things that they least like, for instance, about deforestation. So this is a measure of the climate regulation services of the native vegetation, and you put that together, and we get our third component here, the environmental services map. So you put all that stuff together, and we get a map, which is sort of a composite of a whole bunch of different things, which more or less says, what are the most important natural environments on the planet? And one of the first things you realize, of course, is that it's not evenly distributed. There is certain real estate on Earth that's really important, and if we're going to measure it using the ways that we know how to measure it. And there's other things that are, moderately important in other environments that tend to be somewhat less important. So that's one major part of this analysis. We also included, by the way, protected areas, which is something like 178,000 protected areas across the planet, because we know that if you put a road into a protected area, in many cases you increase things like roadkill and poaching and illegal colonization and illegal activity in many parts of the world. Not all parts of the world. In places where there's strong rule of law, it's not as much of a problem. But we still see negative relationships between road access and many species of wildlife, even in areas where there's not a lot of illegal activity. Then we want to say, well, where are roads going to have benefits? Where are they going to be most beneficial? And again, this is looking at places like, for instance, one of the key layers that went into this is areas where we already have agricultural activity. So most of the native vegetation has already been removed for farming or for grazing. A second thing that goes into this are yield gaps. Now this is identifying the places on the planet where you've got agriculture, but where the agriculture is not very productive. And so we're saying, what's the difference between what's currently being produced and what could be produced if you had better agriculture? So that includes better transportation. It's also going to require other things. It's going to require investments. It's going to require better cultivars, better varieties. It's going to require better farming technologies. It'll probably bring in social changes as well, because there'll be probably consolidation of smaller farms into larger farms, because those tend to be more efficient. There's a variety of things that can facilitate that. But the bottom line is this is where we tend to see major yield gaps. These are the parts of the world, and unfortunately these data are coarse, they're just at a national level, but these are the countries which are going to have the largest projected increases in agricultural demand as a result of rising populations, or in some cases because they're anticipating having major export markets. So it's basically, we can see that some parts of the world, places like sub-Saharan Africa, some parts of Asia, some parts of Latin America, are going to foresee a need and a demand for increased agricultural production. So that goes into the model. Access to markets is another issue. We want to see road improvements in areas where it's economically feasible to get the crops to markets, but you wouldn't want to put, even if you had everything else lined, all the other ducks lined up, you wouldn't want to probably try to start farming out in the middle of the Sahara Desert or the middle of the Amazon Basin, because you'd still be 1,000 kilometers from your nearest urban market. So the idea is to be, within some reasonable distance, typically 2 to 3 hours driving time of an urban market. And then the final thing is soil fertility and climate, because we obviously have to look at that. Some parts of the world can support agriculture because of their environmental conditions, and some places are just too dry, or the soils are nutrient starved, or something like that. So you put all that stuff together, and that was in a fairly complicated way, and you end up with this so-called global map of road benefits. And this basically says where, the redder it is the areas where the potential benefits of road building are likely to be the highest. So the question then becomes, what happens if we then overlay the road cost layer, which is the environmental values layer, with the road benefits layer, which is the basically says where we're going to get the best benefit for humanity and for food production. And you do that, and what you end up with are 4 zones. Green zones, in this particular, this is a very, very simplified analysis here. Green zones are where you've got above median values for environmental values and below median values for road benefits. In other words, these are the places in the world where we really want to emphasize protection wherever we can, because the costs, the environmental costs of road building will be high and the benefits will not be that great. Red areas are where the environmental values are relatively low, but the road benefits values are relatively high. Black areas are what we call conflict zones. These are where both are high. Okay, so you've got high environmental values and you've got high potential benefits of road building. And the white areas, the lighter colors, the white areas are low for both of those things. So these are sort of low priority or low tension zones, things like the Sahara Desert and some parts of the middle of Australia, for instance. Well, and also what we want to do is bring protected areas in there. So if we compare those, this is without protected areas, and once we bring protected areas into that, we bring some additional green into the map, because those are also going to be priorities for protection. So what we end up with by doing here is a very, at this particular scale, is a very coarse prioritization of the risks and rewards of road building across the planet. Now, that, again, was just using 4 colors. This is a more nuanced scheme in which we actually divide things up into 100 colors. Okay, so in this case, we have 10 different gradations of environmental value, and we have 10 different gradations of road benefit. And you can see here, it's a more complicated and more nuanced picture. But the bottom line is, what this is then is sort of a first attempt to try to bring a global perspective into the costs and benefits of road building. And there's a number of different things. Now, actual road planning is not going to occur at a global scale. It's going to occur at a national scale or at a regional scale. And so what we anticipate is that what we hope is that people will take a perspective like this and a map like this and then incorporate it with finer scale local information, with local information on crops and on detailed information on roads and economies and things. But what you see, nonetheless, is that there's some interesting patterns here. We see, for instance, that there's a lot of conflict areas. I mean, large areas, for instance, of Southeast Asia have a lot of conflict. Although, for instance, India has considerable potential for agricultural improvements in parts of Australia. We also see considerable areas like the Amazon basin where the environmental values are extremely high. Considerable areas of potential conflict areas, particularly in places like the Andes, but some areas where agriculture can be improved. Probably the most frightening scenario of all is sub-Saharan Africa right now. Africa is projected by the United Nations projected to see almost a 400% increase in its population by the latter part of the century. It also has very high environmental values in much of the African continent, and there's going to be a clash, very likely a very serious clash, between environmental values and the food demand and other issues that are going to be promoting road building. So that, to me, is one of the most frightening scenarios, is sub-Saharan Africa and also Madagascar. So I'm calling these preliminary conclusions, even though we published the result right now, because, look, this is a very complicated thing. We've tried to look at a big, difficult, thorny, wicked issue and trying to break it down into, and to say, can we look at this in a global way? But there's both sort of good news and bad news from this. The good news is, according to this kind of analysis, every continent does have substantial areas where there's potential for agricultural improvements with relatively modest environmental costs. So that's the good news. The bad news, however, is that there's a lot of conflict areas. So places like sub-Saharan Africa, Madagascar, the Andes, the Brazilian Atlantic forests, West Africa, Southeast Asia, many areas. I mean, there are just many different conflict areas that we're going to have to be worrying about in the future. There are going to be many important environmental debates and battles fought over these kinds of issues. Some very basic regional trends. The Amazon really comes out, for instance, as a place that's unambiguously green. The environmental costs relative to the benefits of large-scale development there are just, for instance, really, really strongly oriented towards environmental benefits. However, India, which is the most populous country on the planet, and it's still growing, does fortunately have considerable potential for agricultural improvements and yield increases, and that's obviously good news for a place like that. So some sort of bottom line take-home messages here. You know, we're living in the most explosive era of road expansion in human history. Roads change everything. They profoundly affect land use dynamics, human dynamics, economies, and one of the really frightening scenarios from my perspective as an environmental scientist is where we're seeing the world's last surviving wilderness areas, particularly tropical wildernesses, are now being inundated with new roads. There's a tremendous proliferation of road activity in the most biologically diverse and environmentally important ecosystems on the planet. That is a frightening scenario, and we really do have to be concerned about these types of things. What we really need is more proactive land use planning. You know, people often talk about things like, let's improve agriculture because that'll promote land sparing. This is one of the common ideas. Let's make agriculture better, and that'll spare land. But high agricultural productivity by itself will not spare land. Look at oil palm. Oil palm is an incredibly profitable crop, and it's just spreading like a tsunami across the planet. Agricultural productivity alone is not enough. The other side of the coin is we have to have land use zoning. We have to have rule of law. We need a proactive approach to identify the critical environments, and that, in concert with agricultural improvements, is one of the most important things that we can do to feed a rapidly growing planet and also try to protect some of our most important environments. Thank you.
Thank you very much for that, Bill, that very detailed work and very recent work. With some alarming points but some very clear suggestions. And if we've got the time, I've got some questions on who is actually going to implement those suggestions. Everyone's got competing priorities.